Welcome to Pure Math 030. This is an exercise on replacements. Now, that title doesn't give you a whole lot of information, but what it's dealing with is what happens when x and y are replaced with specific factors and the effect it has on the graph. And there's nothing new happening in this one, but it summarizes what we've been looking at and provides us with a new, sort of a different way of looking at things. So if we begin, describe what happens to y equal f of x after the following replacements. Now this is in general, any function y equal f of x, and if x is replaced with 2x. So we go y equal f at 2x. This is one of the more straightforward ones, because as you've seen several times, it's just a horizontal stretch by the reciprocal of that 2, so 1/2 about the y-axis. Then, if x is replaced with x plus 3, so the function now looks like y equal f at x plus 3. And this tells us that it's a horizontal translation of 3 units left. Now we're accustomed to this where whatever the x replacement is, whatever the setup in the function, that it's opposite. So if it's x plus 3, it's 3 to the negative direction. Here with y, if y is replaced with 2y, we'll get this. And most people are inclined to isolate the y, giving you y equal 1/2 f at x. That's the conventional way to look at it. And at this point you could observe that we have a vertical stretch by 1/2 about the x-axis. The point that I would like to draw your attention to is that this was identical to what we saw in the previous one. So at the replacement level, there's no difference between the x and the y variables. It's just because you typically isolate the y that things change. Then if we replace y with y plus 3, let's see what happens. Y plus 3 equal f at x. Most people are inclined to isolate the y, so they get y equal f at x minus 3. And this tells us there's the vertical translation of 3 units down. However, had you left it in the y plus 3 equal f at x, you'll see that it behaves exactly like a horizontal one, which is to say that it's opposite the sign. So if we generalize this, we could say that for y equal f at x in general, if x is replaced with bx, we will get a horizontal stretch by a factor of 1 over b about the y-axis. We've seen it all the time. If y is replaced with ay, then we get a vertical stretch by a factor of 1 over a about the x-axis. So they're behaving exactly the same. If x is replaced with x minus h, this produces a horizontal translation of h units. If y is replaced with y minus k, this produces a vertical translation of k units. So everything is exactly the same as long as you're dealing with the initial substitution, or at the replacement level. The difference is that normally we isolate the y, which reverses the way it is for y. Now most people, when they're doing these, like to isolate the y. So the thing that I've just been doing, they don't pay a lot of attention to. They're aware of it, but you pretty much can avoid dealing with it, except in the rare specific question. Now this is a type of thing where we're working with equations, and we are dealing with kind of what we just covered. Here you're given an unknown function. F at x is equal to 1 over the square root of x squared plus 4. And we want to get equations for and also to describe the following. First one, y is equal to f at negative 2x. So we're plugging it into the function shown at the right. Don't think, replace. Everywhere you see an x, you replace it with negative 2x. Don't forget the bracket. And then, to clean up that bracket, you'll get negative 2 squared is 4, and then x squared plus 4. Now, some of you might be thinking that you could go further with that by taking out a factor of 4. And yes, you actually could, but I'll leave it in this form just for convenience. It illustrates the point well. Now, in terms of the description, if we were asked to find, to say what has happened, we would note that because x was replaced with negative x, we get a reflection in the y-axis. And of course, the replacement with the 2 tells us that there's a horizontal stretch by a factor of 1/2 about the y-axis. So the questions can be either or. Let's look at another one. 2y is equal to f at x plus 1. So we're going into that function again. So I replace the y with 2y, and then I replace the x with x plus 1. Now you could FOIL that x plus 1 out. I'm not going to bother. But I will divide by 2 to put it in the conventional form, and this can be a little tricky. Dividing by 2 is multiplying by 1/2. And you could leave it in that form, or you could run the 1/2, multiply it right into that expression and get that. And with respect to the description of this, we replaced y with 2y. And that tells us there's a vertical stretch about the x-axis by 1/2. You could recognize it in the final form when y is isolated, or you could recognize it initially. And then the x plus 1 would indicate a horizontal translation of 1 unit left. So those are some examples and the rules for replacements. Thank you for your time.